In this video, we're using Pythagoras' theorem to find out the length of a shorter side. So these two sides here next to the right angle are two shorter sides. The longer side is the hypotenuse. The first thing I'm going to do is label the sides. This longer side here is C, and the other two are A and B. It doesn't matter which one's A and which one's B. So now let's do an example. Here's an example where I've got a 3 here on this short side and a 5 here, and this one down here, which is the one I don't know. So I better label that. I'll make it X. I'm trying to find what X is. Now in this equation here, in this formula here, A squared plus B squared equals C squared, I need to make sure I've labelled it. So C, A, B. C is always the longest side, opposite the right angle, doesn't touch the right angle. These two sides are touching the right angle. They're the shorter sides. So in this example, we're going to be looking at finding one of the shorter sides. In this case, this value down here, whatever it is. So first of all, I've got my formula, and the next thing I need to do is substitute the values in. So the formula says that A squared plus B squared equals C squared. Now A, I know, is 3. So it means I can write 3 squared instead of A. I don't know what B squared is, or what this side is, so I'm going to leave that as B squared. On the right hand side of the equal sign, I do know what C is. C is worth 5, so I substitute by putting a 5 there instead of C. So you can see that this formula says A squared, and I've put 3 squared. B squared, and I've left it as B squared because B this time is the one I don't know. It's the variable I don't know the value of. And C squared, well, I've replaced C, or substituted C, with the number 5 because C is worth 5. So my diagram is helping me use the formula to know where to put the numbers and letters. Once I've done that, I just need to solve that equation. To solve it, I look and see what I can do first. I can do 3 squared. 3 squared is 9. I can't do anything with B squared because I don't know what B is. I can work out 5 squared, that's 25. Now I've got a bit of a conundrum here because the thing that I'm trying to do is end up at the bottom with B equals. When I look at this equation, there's a 9 and a squared that stops me having B by itself. B needs to be by itself, B needs to be the subject. When I get to this stage here where B is by itself, I know I've got the answer. So what I need to do is get rid of the 9 and the squared. Now I can't just get rid of them. I've got to do something mathematical to make them go from where they are to somewhere else. And the trick is, this is a plus 9, so I'm going to subtract 9. So I'll rewrite the equation like this just so you can see. So 9 plus B equals 25. And I'm going to do something to both sides of the equation. I'm going to take away 9. When I do that, 9 take away 9 is 0, which is why I did it. Oops, I left the squared off, put it back. And what I'm left with now is B squared equals 25 take away 9, which is 16. So B squared equals 16. What's stopping B being by itself now, or B being the subject, is the squared. So I need to do the opposite of squaring, which is square root. Square root both sides of the equation. The square and the square root are opposites or inverses, so I end up with just B on this side. B squared square rooted goes back to being just B. On the right hand side of the equation, the square root of 16 is 4. So the answer for this rectangle is that this side here, B, is worth 4 meters. Here's another example. I better start off by labelling the triangle. So let's put C there, A here, B here. Be careful, I've just noticed that this is in centimetres and that's in metres. So they need to be in the same units. So I'm going to change that to 0.5 metres. So now I've got both of these in metres. Here's my equation. It's telling me how to work out the answer. I need to substitute for A. Well, I can't because I don't know what A is, so that's the one I'm trying to work out. I need to substitute for b. Well, I can do that. So let's go through it. I don't know what a squared, or don't know what a is. I'll leave that as a squared. B is 0.5 metres. And this is telling me, because I've labelled it, I know which one's which. So b is 0.5, so I need 0.5 squared. And c is 0.7. So that's going to be 0.7 squared. Let's work out the bits I know. A squared I can't really work out. I don't know what a is. But 0.5 squared, I can do that. That's 0.25. And 7 squared, 0.7 squared, I can do that. That's 0.49, sorry. Now, I need to get a by itself again. I need to make a the subject. What's stopping it being by itself? What's stopping it being the subject is this squared and the 0.25. So I need to get rid of them. So I'm going to get rid of the 0.25 first. And I'll just rewrite that so you can see what's going on. I'm going to subtract 0.25 from both sides of the equation. I need to do it to both sides. If I don't do it to both sides, the equation won't be balanced anymore. It won't be equal. These two make nothing, which is why I did it. 0.25 take away 0.25 is nothing. A squared, therefore, is equal to 0.49 take away 0.25, which is 0.24. To work out what a is, I need to get rid of the squared sign, so I square root both sides, and the square and the square root cancel each other out because they're inverses, and a ends up being the square root of 0.24. 0.49 metres. So I've worked out that this side up here is 0.49 metres long.